Okay guys, in this video lesson, we're going to take a look at this idea of our positive particles and our negative particles and how they interact with each other and generate a field of force, okay? So first we want to look at is kind of how we draw these things up a little bit. If you have a single particle like this, we're going to draw the lines moving away from a positive particle like this, okay? Those field or these field lines represent the direction of flow that we would see if we were to put a positive particle inside of this electric field, okay? Now, that kind of information is over here in these two bullet points, but I want to focus kind of down on this one, all right? So when you think of this, what I want you to think about is that this electric force is establishing a field, okay? What we mean by that is establishing an area in which it affects, okay? We have gravitational fields, we have magnetic fields, and we have electric fields about them, all right? Earlier in the year, we talked about contact forces and field forces. Well, electric forces are field forces, so they actually generate a field or a pattern to how they pull and push different particles, all right? If we take a look at this system and take a look at the lines in particular and how we draw them, the first thing we wanted to establish is how do we draw lines about a positive particle? How do we draw lines about a negative particle? Okay, so right now this is an isolated charge, all right? So assume there's a barrier between A and B that they're not interacting with each other at all here. So I would even like draw a line or do something here to represent that they're not interacting at all, okay? If all you have is a single positive particle, we draw a line spanning out from it, and we draw arrowheads moving away from it. So we have these particles moving away, 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 okay? The reason we do that is because we assume that the particle inside this field is going to be a positive particle, okay? Not that it can't be a negative one, but we draw it always showing what would happen if a positive particle came within this field, okay? Keeping that in mind, we go over to the negative particle. In a negative particle, if you put a positive particle in this field, it would be drawn towards it because the negative and positive would attract each other. So here we draw the exact same thing, but now the arrows are all pointing inwards or towards the negative. Okay? So what that means for us is that we're always going to point the arrows away from a positive and always towards a negative. Now, if we get into a situation where we have multiple particles within the same region, okay? And that's where we actually start to look at it and it becomes more powerful for us. So if we had a positive charge and a negative charge in the vicinity of each other, this positive charge would generate a field that would push another positive particle away, but this negative charge would then also pull it in. Okay, so we see that in this case we all have these curving lines now. So what happens is they actually start to curve towards the negative. Okay, there's one mistake on this little picture here. This arrow here is backwards, so that should also be pointing inwards. Same thing over here. So just in case you notice that, these should all be pointing in towards this negative sign. Not sure why it was drawn backwards, but this is actually a mistake. These should be pointing inwards. Okay. Now, in this case, what this means for us is that if I placed a particle right here that was positively charged, it would move and attract itself to that negative side, okay? If I put a negative particle in, it would run opposite of what this field shows. So a plus and a minus have these curving lines that move towards each other. If we have two positive charged particles, what we see is that positive charged particles actually push away from each other. So if you had two pluses coming close to each other, the fields would actually oppose each other and repel. Okay, so we see that repulsion being shown here with inside this a positive and a positive put together. Now, one thing not shown on these lines is kind of the strength or the magnitude of the charge. Okay, one way that we represent that is we represent it by the number of lines. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines coming off of this positive charge. If I want to represent that meaning more powerful, so having more force or maybe more charge there, what I can do is I can draw more lines in closer together. Okay, so it's not shown here, but if we wanted to show this being more powerful, we would put maybe one line here, another line here, another line here. We would show additional lines representing more strength to that. Okay, if we wanted to have it show it less powerful, we would take some lines away. Okay, so what can happen is if you have two positive fields and this one has a whole bunch of lines on it and this one had very few, this positive field can actually kind of overwhelm the other one and kind of dominate that field if we see that happening. All right. And then last thing to remember is that we're always looking at this through the lens of how a positive charged particle would move. Now we're going to kick out here and we're going to go to a little applet for us to take a look at. And this is done by FET, which is another one. We've used these before. And I'm just going to put a positive charge particle in our field. And I'm going to put a grid up here so we kind of see that gridded out. And I'm going to put some voltage in because this looks cooler. And then we're going to take a look and see what's going on here. So if you notice a couple of things, from the plus sign, all the arrows are pointing away. And then also you notice it's really bright here, really, a lot of white. And as it goes further and further away, it fades away. And that's the way they're visually showing that the strength of this electric field diminishes as you go further and further and further away. Okay. Now, if I put another positive charged particle in the window, what happens is this one has the exact same type of scenario. So they're all pushing against each other. Okay. Notice how they come out, and when they hit each other, they kind of push away from each other. If I bring this closer to this, we notice how that push becomes more dramatic inside of our forces here, right? So that would be plus with a plus in terms of attracting each other in our fields, all right? Now, if I reset this and we have a positive charge particle sitting here and we have a negative charge particle, what we see now is that positive charge particle still is showing field lines going away from it, but it is moving towards that negative charge particle. So with that negative charge particle, this is attracting a positive thing. This would be repelling that in terms of what we have here. Okay? So we see a difference there. Now, you can put multiple particles in, and you see as I add more and more particles how we can actually change these field lines inside of a system. So we see a lot of different variety to that. Okay? Now, last thing we want to do with this is we want to put in, let's say, a positive charged particle, a negative charged particle, and we're going to add more and more particles to the same location. And you notice how it gets brighter and brighter and brighter because we are increasing the magnitude of this force. So instead of drawing in more lines, this animation chose to actually color in the whiteness of this more, okay? And if we take a look at our sensor, I bring this thing in, this is representing where the force is at. Notice how it's attracting always towards that negative. And as I bring this closer and closer and closer to this, we're going to see that the power or the magnitude of that force increases greatly as we take a look at this. Okay? All right, guys, that's just kind of an introduction to the field lines and what they are. We use these to represent what would happen to those positive particles if they were attached to each other. Thanks.